where we will be introducing you to how antivirus solutions work and how they detect malware, as well as how they can be evaded, right? So in this specific video, we're going to be taking a look at a very simple example whereby we'll be injecting reverse shellcode into a legitimate Windows executable, and that will serve two functions. Number one, it'll make the actual final executable look legitimate because, for example, we can actually take a look at how to inject our reverse shellcode into a program like WinRAR or Google Chrome. And again, as I said, that serves two functions. That'll make it look legitimate so that the end user or your target will not be able to tell outrightly that that program is malicious. And secondly, this is an actual antivirus evasion technique. And this is pertinent to signature-based detection. So we're really going to be focused on the fundamentals within this section and within this course, primarily because antivirus evasion or defense evasion in general is a very complex topic that is multi-tiered and involves multiple techniques, tools, and of course, you also have to take into consideration the vast number of EDRs or antivirus solutions out there. So you might be asking yourself, well, why does all of this matter? Well, if we are able to generate an executable that when executed provides us with a reverse shell, that may evade Windows Defender, but it might not evade Malwarebytes, for example. So again, given the fact that, the actual landscape or the digital IT industry currently has more than 100 antivirus solutions out there, it can be a very, very complex process. So we're essentially going to be focused on the fundamentals here. And as I said, in this example, we're going to be taking a look at how to evade very basic signature-based antivirus solutions by injecting our malicious shellcode, our malicious reverse shellcode into a legitimate executable with Shellter. So before we actually get started, let's get an understanding of defense evasion as a topic, right? So this definition is, I actually pulled it from the MITRE website. And the reason I did that is because it perfectly encapsulates the complexity of this topic. So defense evasion consists of techniques that adversaries use to avoid detection throughout their compromise. Techniques used for defense evasion include uninstalling or disabling the security software or the antivirus, or obfuscating or encrypting data and scripts. Adversaries also leverage and abuse trusted processes to hide and masquerade their malware. Now, the area that we're focusing on here is obfuscation and encryption, right? So what we're trying to do is we're trying to change the signature of the malicious executable that we're generating. So, for example, if I generate a Meterpreter payload with MSF Venom, if you transfer that onto a Windows system, a modern Windows system like Windows 10, that will be detected immediately. Well, why is that? How does an antivirus solution actually know that that is malicious? Well, that can be explained by getting an understanding of the various antivirus detection methods. So antivirus software will typically utilize signature, heuristic, and behavior-based detection. So let's get started with signature-based detection first. So this is the oldest and most commonly used detection method, and it's still used by antivirus solutions out there, even extremely powerful antivirus solutions, one of which is Windows Defender. But Windows Defender and, some of the really advanced commercial antiviruses actually use a combination of more than one of these detection methods to ensure that they're able to uniquely or rather accurately identify malware whenever it's downloaded onto your system or whenever an attacker, is able to get that malware onto your system. So the way signature-based detection works is the antivirus software has a database of virus signatures or malware signatures, right? And so what is an antivirus or a malware or virus signature? A virus signature is a unique sequence of bytes, or rather a unique string of text that uniquely identifies malware or files or executables that are malicious. Right now, how is this signature generated? Well, again, the easiest way that this is done is to just generate a hash of that executable or to get the hash value of that executable, right? And I'll not dive into that right now because that's really not within the scope of this course itself. But the way this works is whenever there's a new virus that has been developed or, for example, new ransomware, the antivirus company will actually have one of their engineers go ahead and download that malware sample into a secured environment. What they will then do is analyze it, and part of their analysis, and that's malware analysis, will actually consist of generating a signature, a unique signature that uniquely identifies that malware. That signature is then what is included within the antivirus solutions signature database. So whenever you download and install an antivirus solution that utilizes a signature-based detection, it comes with a database of signatures. So let's take a look at a simple example. If I download Google Chrome, for example, right? I download the Google Chrome setup. Once that file is saved on my disk, the antivirus solution goes to work and actually generates a hash of that executable, and then compares that hash, or that signature, if you will, to its own signatures within the signature database. If it matches, then that means that that executable is malware. If it doesn't find a match, then again, it's not flagged as malware or as a virus. So in terms of evading signature-based detection, we can do this by modifying the malicious executable or the malware's byte sequence, therefore changing the signature. So whenever an exploit developer creates a new piece of malware or ransomware, and a signature is generated or made for that particular piece of malware, that particular executable will be detected. So again, going back to the example of generating a meterpreter payload with MSF Venom, if I generate a meterpreter payload with MSF Venom, transfer it over to the target, the antivirus solution will pretty much have a signature that matches that the actual signature or hash of the meterpreter payload. But if we modify the byte sequence of that meterpreter payload, the actual hash of that executable or meterpreter payload changes. Consequently, meaning that if that new hash is not, if that new hash cannot be matched to an existing signature within the antivirus signature database, then it's not going to be flagged as malware. Now, as I said, antivirus companies have an extensive database of signatures, so you really have to, you really have to be smart about, what you're doing. And the easiest way in this particular case is to inject our shellcode that we will generate with meterpreter into a legitimate executable, therefore masking or generating a signature that is that again in most cases will not be included, or generating a new signature that is not part of an antivirus solutions signature database. So that's signature-based detection. We then have heuristic-based detection. This relies on rules or decisions to determine whether a binary or executable is malicious. It also looks for specific patterns within the code or program calls that have been made by a particular executable. We then have behavior-based detection. This relies on identifying malware by monitoring its behavior. And this is typically used or is very effective against new strains of malware. And again, the way behavior-based detection works is this particular system involves taking a look at what a program does when it's executed. Is it actually taking a look at the Windows registry? Is it doing anything that is considered suspicious? And if so, then that's going to be flagged as malicious, or it's going to be flagged as dangerous, right? So these are the antivirus detection methods. Now, in terms of the evasion techniques, there really are. You can really categorize these into two, or split them up into two, right? So you have on-disk evasion, and this is your typical scenario, right? When you generate a meterpreter payload, that needs to be transferred over to the target, and if it's then executed, if it's transferred over to the target, it's going to be stored on the target system's disk. So this is where on-disk evasion techniques come into play. So whenever an executable or a malicious file is saved onto the disk, we actually need to utilize different evasion techniques as opposed to in-memory evasion techniques. So number one, in terms of on-disk evasion techniques, we have obfuscation. Obfuscation refers to the process of concealing something important, valuable, or critical. And what obfuscation does is it reorganizes code in order to make it harder to analyze or to reverse engineer. You then have encoding, right? So encoding data is a process of that involves the changing of data into a new format using an encoding scheme. An example of encoding is encoding a particular string of text into base 64. The problem with encoding is that it is easily reversible, right? Which means that if you know what if you actually identify a piece of code that's been encoded in base 64, if you can tell that it's been encoded in base 64, then you can decode it very easily, right? So that's encoding. You then have packing. So packing essentially involves the process of generating an executable with a new binary structure with a smaller size, and therefore provides the payload with a new signature. This is typically used by various malicious attackers whenever they're trying to generate executables that will consequently give them remote access to a system, etc., etc. You then have cryptors. Cryptors essentially encrypt code or payloads and decrypts the encrypted code in memory. The decryption key or function is usually stored in a stub. So this is one of the techniques that's typically used by new strains of ransomware, whereby the actual code is encrypted, right? And encryption cannot be whenever you come across encrypted code, you cannot decode that. You actually need the key, the actual decryption key, to decode it. And in the case of ransomware, only the ransomware developers have that key. And that's why whenever a system gets infected with ransomware, they ask you, they essentially ask you to pay a specific amount of money. They'll then send you the decryption, the actual decryption key to decrypt your files, right? So that's how cryptors work. So those are on-disk evasion techniques. We then have, your in-memory evasion techniques. So in the context of antivirus evasion, in-memory evasion techniques focuses on manipulation of memory and does not write files to disk. It involves injecting payloads into a process by leveraging various Windows APIs. And payload, again, the payload is then executed in memory in a separate thread. So this involves evading antivirus detection in memory, right? So this is an advanced technique that we will not be covering within this section, probably in an advanced course or certification. All right, so let's actually take a look at how we can inject, shellcode into a legitimate executable, and how that can be used to evade an antivirus, a very basic antivirus detection. And in this case, what we'll be doing is we'll be trying to evade Windows Defender on a Windows 7 system. So this video does not have a lab environment attached to it. As I said, you can follow along and take a look at the various tools I'm using. All of these tools can be installed on Kali Linux without any issue. And you can try and replicate this within your own lab environment. So I'll just switch over to my Kali VM and we can get started. All right, so I'm back on my Kali VM, and let's get an introduction to Shellter, because that's the actual tool we're going to be using. Now, you can install Shellter on Kali Linux, as the package is a part of the official Kali Linux repositories, but you can head over to the shelterproject.com to learn more about Shellter and how it works. So let's get an introduction to Shellter. All right, so Shellter is a dynamic shellcode injection tool and the first truly dynamic portable executable infector ever created. It can be used in order to inject shellcode into native Windows applications, currently 32-bit applications only, so keep that in mind. The shellcode can be something yours or something generated through a framework such as Metasploit. Shellter takes advantage of the original structure of the portable executable file and doesn't apply any modification, such as changing memory access permissions in sections unless the user wants to do so, adding an extra section with read, write, and execute access, and whatever would look dodgy under an antivirus scan. Shellter uses a unique dynamic approach which is based on the execution flow of the target application. And this is just the tip, the actual tip of the iceberg. Shellter is not just an EPO infector that tries to find a location to inject or insert an instruction into to redirect execution to the payload. Unlike any other infector, Shellter's advanced infection engine never transfers the execution flow to a code cave or to an added section in the infected portable executable file. All right, so the really cool features with Shellter is that, again, it's compatible with Windows x86 and x64, and it works on Windows XP Service Pack 3 and above, or newer versions of Windows. And again, it works with Wine and of course Linux. It works with Wine. So whenever you install the Shellter package on your Linux system, because it's an executable, you actually need Wine. Wine is a compatibility layer for Linux that allows users on Linux or Unix operating systems to execute exe files. The great thing is that it's portable, so no setup is required. It doesn't require dependencies. That's fantastic. It doesn't have any static PE or portable executable templates. It supports any 32-bit payload, and it's compatible with all types of encoding by Metasploit, compatible with custom encoding created by the user, so you can specify whether you want to go through additional encoding. And I've already covered within the Metasploit framework course how to encode a payload with MSF Venom, and how that can also be used to evade very basic antivirus solutions that utilize signature-based detection. All right, so in order to install Shellter, you can simply type in sudo apt-get install Shellter here, and that should install the Shellter package for you. However, there's a very important aspect that you need to take into consideration here. The Shellter package is really a Windows executable. Now, how will you run a Windows executable on Linux? Well, that can be facilitated through the use of a tool called Wine. All right, so you may have heard of Wine before. Wine is a compatibility layer for Linux that allows you to execute Windows executables on a Linux system or on a Unix system like Mac. So after installing the actual Shellter package, you then need to install Wine. Now, the specific architecture or the package that we'll be installing in regards to Wine is the Wine 32-bit package. And this is primarily because Shellter only supports 32-bit payloads, or rather supports the generation of shellcode of 32-bit shellcode, right? So we actually need to configure the Debian package management utility to essentially allow us to install 32-bit packages, because right now the current Kali Linux VM that I'm utilizing is 64-bit, and the Debian package management utility has of course been already configured to only install 64-bit packages. So to install 32-bit packages, we will need to run the following command. So we can say dpkg, all right, so that's the Debian package management utility. So dpkg, and we say add, and we can say architecture. Let me just type that in correctly. So that's architecture. And we then specify i386, that's for 32-bit, so i386. And we can then hit enter. And in some cases, it may ask you for root permissions. So I'll say sudo dpkg add architecture, and that's done. I can now install, Wine 32. So I can say sudo apt get install Wine 32, which I currently already have, as you can see, and I'm currently using the latest version, and that has been installed successfully. So at this point, you can now execute the Shellter executable with Wine or with Wine 32 in this case. So let's take a look at how we can do that. You can head over into user, share, Windows resources, not Windows binaries, but Windows resources, and you'll have a folder called Shellter. So within the Shellter directory, you can see that you'll pretty much only have the Shellter executable. Disregard these two folders, as these folders will be created once you actually execute Shellter itself, right? So we have shelter.exe. So how do you execute an exe file on Linux? Well, we can do that with Wine. So in order to execute it, we'll say sudo wine and then the actual exe. So shelter shelter.exe. There we are. I'll hit enter. And that's going to start up Shellter. So we don't have any issues there, and we can get started. So let's get started with the actual injection process. However, before we do that, we need to identify a legitimate executable that we can actually inject our shellcode into. So this is where the whole social engineering aspect of things comes into play. So you can download an executable. I would recommend that the executable is very small and very simplistic in terms of its functionality. This will probably not work if you try and inject your shellcode into an executable like the Chrome installer or VLC or anything like that. So on the Kali Linux system, if I head over into the file system here under user and under share, we have a directory called Windows binaries that contains a list of executables that again are used during a pen test or during a security assessment, and one of them is VNC Viewer. So if you're not familiar with VNC Viewer, this is a very simple Windows program. It's not malicious at all. It's completely legitimate. And it's essentially used to connect to a VNC session or to essentially establish a VNC session, right? So it's just a utility that allows you to essentially connect to a server or to a target system and establish a VNC session. So we can inject our shellcode into this executable. So I'll just make a copy and I'll head over into my desktop and I'll go into the folder called AV Bypass, which I created, and I recommend that you do the same. So this is the original executable. Now, the great thing with Shellter is that whenever you perform the injection, a copy of this will be made. So a backup of the original will be made, and it will actually be stored under the user share Windows resources Shellter directory within Shellter backups. So you can always get the original back. But now that we've identified the actual legitimate executable that we would like to inject our shellcode into, and we've saved it within a directory that we are familiar with, we can actually begin the injection process. So I'll just launch Shellter again, and it's going to ask you to choose your operation mode. For the purpose of this demonstration, I'm going to say auto. We then have the PE target. This is the portable executable target, or the legitimate executable that you'd like to inject your shellcode into. You need to specify the path to the actual executable. In this case, mine is being stored under home, under the Kali directory on my desktop in a folder called AV Bypass. And the name of the executable is VNC Viewer.exe. So I'll hit enter. You can see it's going to make a backup and it will store it under Shellter backups VNC Viewer.exe. It's then going to again take a look at whether or not the executable has been packed. You can see that it's not packed. It'll then move on to PE info elimination. It'll take a look at the DLL characteristics, and it'll provide you the status here. So all related information has been eliminated. So that's changing the signature as much as possible. You then have your tracing mode. So again, if you take a look at the note here, you can see that in auto mode, Shellter will trace a random number of instructions for a maximum time of approximately 30 seconds in native Windows hosts and for 60 seconds when used in Wine. So it's essentially tracing and identifying instructions where the shellcode can be injected into. So I'll give this, as it says, up to 60 seconds. All right, so as you can see, that's done. And it's going to tell you instructions traced, 18,574. It's then going to start the first stage filtering. So it's going to ask you whether you want to enable stealth mode. Stealth mode, where this is a very important step, because what it's asking you is whether you want the executable to function as intended. So for example, in this case, we are injecting the shellcode into VNC Viewer.exe. So it's asking us whether or not we want VNC Viewer to actually function as normal, or to actually function normally when executed. So if we want that to happen, which I recommend that you do, I would enable stealth mode. So what that means is that whenever the target will click on the new VNC viewer that we're going to be generating, or that contains the injected shellcode, VNC viewer will function as normal, but the shellcode will be executed in the background, right? So we'll say yes. It's then going to ask you for the payload that you'd like to use. So this is where the shellcode injection process comes into play. So again, you can obtain a meterpreter session on the target, and you can again identify which of these stages or payloads you'd like to use. And based on your option, it's then going to generate the shellcode appropriately. So for example, if I wanted to obtain a meterpreter session, I could use option 1. So it's going to ask you whether you want to use a listed payload or custom. Now, if you want to go ahead and encode a payload with MSF Venom, firstly, or you want to generate a meterpreter payload and then encode it with MSF Venom, you can do that and then specify a custom, the C option here, and then use that that actual payload itself. However, in this case, we're not going to be doing that. So I'll just say option 1, or I'll say L first to use a listed payload. And then I'll say it's going to ask you to select the payload by index. So I'll say option 1. It's going to ask me for my L host information. So this is going to be the attacker's IP address. And in my case, my Kali Linux IP is 10.10.10.10. The port is 1234. I'll hit enter. And it's now going to begin the basic obfuscation. And we can see it right over here, polymorphic junk code. It's going to generate some junk code there. And the most important stage is right over here. So injection stage, it's going to tell you where the shellcode has been injected. And you can see right over here, under PE checksum fix, the valid PE checksum has been set. And under verification, you can see that right over here, injection verified, and we can hit enter to continue. So we now have VNC viewer, but the new executable has the injected shellcode. So remember when I said that Shellter actually takes a backup, it does that for a reason, because the new executable is going to replace the one that was stored within the directory, right? So within this particular directory. So remember, I copied over the legitimate VNC viewer exe to the AV bypass folder. And this is now the malicious executable. So it will take a backup first. It'll then perform the injection, and it's going to replace the older one with the new malicious one. So I can now copy this over to the target system, and you'll see that it looks exactly like VNC viewer. It will function exactly like VNC viewer. The only difference is that when it will be executed, it'll execute the shellcode, our meterpreter payload shellcode, and it'll then connect back to our reverse TCP handler that we will set up in the Metasploit framework right now. So the first thing I want to do is I'm just going to set up or launch MSF console to set up the handler to receive the connection once the shellcode is executed on the target. So I'll give this a couple of seconds, and I'll split my terminal vertically here because we actually need to transfer that executable to the target. So I'll navigate to the directory where the malicious VNC viewer executable is stored. So that's under AV bypass. And I can start a simple web server. So I can use the Python module. So I'll say sudo Python. I can say Python 3 m. We can say http.server, and on port 80. So I'll host all the files within the AV bypass directory on the Kali Linux IP on port 80. So there we are. That's serving all of those files. Now in the Metasploit window here, I'll say use multi-handler to set up the handler or the listener. And then I'll specify the payload that I used when I was essentially generating the shellcode within Shellter, which in this case, in the case of Windows, if you selected the meterpret option, is always going to be the actual 32-bit meterpreter payload. So Windows meterpreter reverse TCP. All right, I then need to set up my lhost option. And of course, these have to match the ones that you had set when generating the actual shellcode within Shellter. So my Kali Linux IP, and then L port we had specified as 1234, and I can hit run. And we can now, again, transfer over that executable. So I'll switch over to the Windows 7 system. Now, the Windows 7 system has Windows Defender enabled, but it's an older version of Windows 7. It's Windows 7 build 7600 and build 7601, and it has it's actually a Service Pack 1 installation. So let's actually see if we are able to bypass basic Windows Defender. So let me just switch over to the Windows system. All right, so I'm back on the Windows system, and again, now the method of delivering the actual malicious executable is entirely up to you. I'm just going to be downloading it from the web server that I set up. So 10.10.10, and we have VNC viewer there. So I'll click on that there, save. I'll save it in downloads, and it looks like we haven't had any detection yet. So it's been saved on disk there. If we take a look at the downloads folder, you can see that it looks exactly like VNC viewer here. So I can also move it to the desktop just so that you can see the icon even more clearly. I think I've zoomed in too much there. So let me just zoom out and let me refresh that there. And we can see the VNC viewer icon here. And let me just get rid of that there. So again, if I click on it, it should work exactly the way VNC Viewer should work. However, in the background, what's going to happen is it's going to execute the actual shellcode that we injected into it. So I'll double click on it, run, and you can see it works. It works as intended, and a person can actually use this for legitimate purposes. But it had it had malicious shellcode injected into it. So this particular executable has not been detected by Windows Defender. So if I switch back over to Kali Linux, you should see that I have received a meterpreter session on my multi-handler listener. All right, so I'm back on Kali Linux, and as you can see, we made a GET request, or we downloaded VNC Viewer on the target system. And once it was executed, we obtained a meterpreter session on the target system. So I can say sysinfo. And you can see Windows 7, build 7601, service pack 1, and I can say get use ID, for example, and we're currently as the Windows 7 user. So that is how to inject shellcode into a legitimate executable for the purpose of evading signature-based antivirus solutions. And that is going to conclude the practical demonstration side of this video.